Maggie is a 40-year-old who has just read that if hydrogen peroxide in her body is not broken down fast enough, it will bleach her hair from the inside out. Knowing that catalase is the enzyme which greatly increases the rate of decomposition of hydrogen peroxide, Maggie designs an experiment to determine if she should take catalase supplements to prevent her hair from bleaching. Catalase lowers the activation energy of the decomposition of hydrogen peroxide into water and oxygen by binding to the substrate at one of its 4 heme active sites. Each heme site contains a prosthetic cofactor, iron 3+ ion, which undergoes a 2-stage reduction oxidization reaction with hydrogen peroxide. The iron ion is then returned to its original oxidization state and is recycled for further reactions. Maggie's hypothesis is that if she increases catalase concentration when it is limiting, it will increase catalase activity since there will be more enzyme active sites for substrate molecules to interact with. She also hypothesizes that once catalase is in excess, increasing catalase concentration will not increase the rate of product formation. To test her hypothesis, Maggie did the following. 5 milliliters of hydrogen peroxide was added to a reaction chamber. Paper discs were then soaked in catalase solution and placed inside. Next, a rubber stopper with tubing was placed in the opening of the reaction chamber. The reaction chamber tubing was then placed inside a water-filled graduated cylinder, and the reaction chamber was turned upside down, causing the catalase on the discs to mix with the hydrogen peroxide. Oxygen was produced as a result, and the amount produced was recorded every 10 seconds for a total of 90 seconds. Maggie conducted 4 different test cases, starting with 1 catalase-soaked disc, increasing to 2, 3, and 4 placed inside the reaction chamber. Based on her experimental design, Maggie was able to compare how a concentration of N discs per 5 milliliters of catalase affected catalase activity. In the experiment, temperature and pH were controlled to ensure that changes in the rate were driven solely by catalase concentration. The results of Maggie's experiment were recorded in this data table. She chose to specifically analyze initial rate as the indicator of catalase activity, as reactions with high catalase concentration went to completion quickly. To do this, she uses oxygen volume produced in the first 10 seconds. Maggie's hypothesis is supported by the data. The increase of oxygen produced in the first 10 seconds with an increase of catalase discs supports a positive correlation between catalase concentration and initial reaction rate. When catalase amount is increased from 1 to 3 discs, there was a directly proportional relationship between the catalase concentration and the initial rate. This trend is observed because as catalase concentration increases, there is an increase of heme active sites available to which substrate molecules can collide and interact. Since these sites facilitate the decomposition of substrate through lowering activation energy, the rate of decomposition is increased. In this situation, every added catalase molecule has a substrate molecule with which it can interact. After the 3rd disc, the increase of rate with additional catalase discs is less. This is because there is a point at which additional enzymes are in excess of the substrate. At the saturation point of catalase, the rate of reaction would be fastest, since for every catalase enzyme active site, there is a matching substrate molecule to convert. Beyond this point, an increase of catalase concentration will not affect the rate of reaction, as it will be in excess to the amount of substrate molecules. This suggests that catalase activity is at its most efficient, that is, being at a maximum rate with no excess when it is saturated. The data suggests that at a concentration of 3 catalase discs per 5 milliliters of hydrogen peroxide, the catalase approaches the point of being in excess. If the trend is extrapolated, it can be seen that at a concentration of approximately 5.5 catalase discs, the effective increase in concentration on rate reaches 0. This supports Maggie's hypothesis that there is a point beyond which additional catalase has no effect on rate since enzyme is not limiting. Maggie realizes that her experimental design could be improved in a number of ways. First, the amount of catalase could be quantified precisely using a micropipette, an improvement upon measuring relative to disc count. Second, the 10-second measurement intervals could miss early reaction kinetics as seen in the graph. To improve upon this, the reaction could be slowed, either by working with more dilute catalase and/or hydrogen peroxide, or working at a cooler temperature which should slow down the catalyzed reaction. This would allow for more accurate comparison of initial rates. Maggie's experiment is relevant because it shows a correlation between catalase concentration and rate of hydrogen peroxide decomposition. Knowing that hydrogen peroxide leads to fading hair color, Catalase could be used in cosmeceuticals to promote hydrogen peroxide decomposition in order to keep hair from losing color. As well, Catalase supplements could be used for people who have ingested high levels of hydrogen peroxide, for instance in poorly made coffee, to speed up its decomposition by raising the Catalase concentration. It is critical to note that in the body, Catalase is the limiting factor to the breakdown of hydrogen peroxide, and thus rate can be increased. Maggie's findings could be useful for both the food and textile industry who rely on Catalase to remove hydrogen peroxide from cheese and fabrics respectively. The experiment suggests that the amount of Catalase used in the production should be held at the point where it is neither limiting or in excess, so production speed is at a maximum without excess enzyme that would increase production cost. After the experiment, Maggie asks herself, what is the point where Catalase concentration is in excess in the liver? What concentration is low enough that hydrogen peroxide is not decomposed fast enough, leading to hair bleaching? How does aging affect Catalase concentration? And could people suffer from Catalase overdose? To answer these questions, an in vivo animal study could be conducted in which lab rats fed fixed amounts of hydrogen peroxide are also treated with Catalase. The amount of hydrogen peroxide that causes hair fading would first be determined and fixed, then Catalase could be administered in increasing amounts until hair lightening is inhibited. Beyond this, Catalase doses could be increased until lab rats showed signs of toxicity. Although not directly compatible, the doses showing activity and toxicity of Catalase in rats could help determine initial doses for testing in humans. In conclusion, Maggie decides to go to her doctor and see if she requires Catalase supplements in order to bring her body's Catalase concentration to the point at which it can break down hydrogen peroxide readily enough to stop her hair from bleaching.